Are you there? Are you there? I can't hear you. Are you there? Are you with me? Okay. Can you hear me?
Yes, I can hear you. I can hear you.
Okay, good. That's what I wanted to hear. So I want you to uh understand that we also have functions that are either odd or even. You see, odd or even function.
Okay.
Even function. So when you talk about even function, for instance, if you have a function of f of x, and then uh when you now do f of minus x, and then it still gives you f of x, then that function is said to be even. A perfect example, if f of x is equal to x squared, you note that even if you do f of minus x, you are still going to have minus x all squared, which is going to be minus x multiplied by minus x, which is going to be x squared, which is going back to the original f of x. Then this kind of function, we call them odd, even function. So this function is even. Then when it is odd, if it is odd function, then odd function, you can say if a function is odd, right? If you take the
Yeah.
negative inside, it should be minus of the function itself. So if this is the case, you can clearly say that that means that you have an odd function. A perfect example is f of x is equal to x cubed. Now, if you look at this, if I say what is f of minus x in this situation, it's going to be f of minus x, but this are minus x, I'm going to put it here. So we have minus x all cubed. This is going to give me minus x multiplied by minus x multiplied by another minus x. So this is going to give me minus x. And you see that this is going to give me minus x cubed, right? So f of x is this guy, right? But if you look at this, this is minus and this is our f of x. So this is same as minus, but this is f of x, f of x. So in this case, this is an odd function. That's that about that. And we're going to, where is limiting limits, the rules in limit. Since we are not going to be rushing it, I'll be giving you all the rules in limit. So the rules of limit is if you're giving the limit of a function, let's say x, as it goes to a particular, let's say a, if the limit of this function is f of x, right? And then we have the limit of another function, the limit of another function. So we can call the function g of x as x tends to a. And then after you solve this limit, these two limits, let's assume this one you got capital A as the answer. And for this one, you got capital B as the answer after you solve this limit. You see, I'm using variables now. So you'll be used to getting variables. So one of the rules is that if I take the limits individually and add them, the solution for the subtraction and the addition should be the same, which means if I take the limit of the function as it goes to a point, right, of this f of x, right, plus g of x. Now, this should be the same thing as I am taking, this is if I combine the both of them together, it should be the same thing as if I am doing them individually. F of x as x tends to a plus the limit of g of x as x tends to a. Now, remember, if you do them, you get a. So here you're going to get a plus b. This is a rule in limits. If I take limit of individual function and add them, it's the same thing as adding the function first before taking the limit. That's a rule. That's rule number one. Now, it's the same thing apply for subtraction. If I subtract two of them before I add two of them, it should be the same thing as when I subtract the two answers together. Are we together? Do you get this point?
Okay.
Emmanuel, are you with me?
Yes, sir. I said yes. Did you hear me?
Okay, you just try to be audible so that I can hear you. And the same thing, if you multiply them, for instance, if you multiply the limit also, if you multiply the limit of f of x and you multiply it with g of x, it should be the same thing when you multiply the final answer. It should be the same thing when you multiply them. Now, division will be the same thing, but now you have to apply this the second one. The third one, division should be the same thing, but remember, let me see if you're following me. So this, if you take the limit, okay, good. If you take the limit divided by as x approaches a, divided by the limit as g approaches a, what should be the condition for this function to hold? What do you think the limit will be?
Oh.
The denominator must not be equal to what?
The numerator.
0, right?
It was not equal to 0, yes.
Good, fantastic. So that's that about that. So clearly, we are now going into what we refer to as differentiation. What is differentiation? If you learn differentiation, you're going to be understanding how to determine the gradient of a straight line graph, evaluate from first principle, differentiate power of polynomials, that polynomial that we have taught, I have mentioned, we are going to be doing that. You're going to learn also how to evaluate second derivative, both using table. You're going to be doing chain rule, quotient rule, and then product rule. That's what we're going to be doing, right? So basically, I'm going to try and introduce you to it today, and if possible, we solve some problem. For example, if I'm giving, if this is a graph, right? Or let me bring it down. Let me bring it down to this point. Good. So if I have this, I can take out this guy. And then let me try my possible best to get another straight line around here. Let me take it from the origin. I don't take it from the origin, right? Let's say we have something like this, and then we have some points. This is y, this is x. So technically, this is the point of origin, but we don't care about it. We can say that this point is a point P. Let's say this point is a point Q. Good. So from this point, this will be a value of x. Let's call it x1. This is another point. So when it intercepts with x, we can call it x2. But if it is going to y, what can we call it?
Minus.
Let's say y1, right? If we are tracing this to touch
Y1.
y, So this one will be y2.
Y2.
Good. Now, in the basic concept of calculus, this place, we call it a change in the value of x. Can you see that it's a change? So it's either you see it as a change like this, or you see it as change in x. Y for the y guy, this should be change in y. This is called change in y. Now, see as I'm writing it, it's like a triangle, but it's small. Now, other textbooks, you can see them as a change in y upon a change in x. But if we use this representation, right? If we use this representation, you can see that this is just y2 minus y1, because I want to get the difference between here and here divided by the difference between here and here, which is x2 minus x1. Are we still together?
So,
Good. So this is now what we call the gradient. This is the gradient or the slope of this graph, right? So basically, if it is just a straight line graph, you can just decide to say, okay, I can just trace the value here. The value here maybe, let's assume this is 4 and this is 2. Let's assume this is, let's say, 3 and then this is 1. Maybe this is 0, 1, 2. Just assumption. If you have to find the slope now, you can just quickly say y2 is 4 upon y1, this is 2, then divided by 1, 3 minus 1. So this is just 2 upon this one, 2 is 2, so this is equal to 1. So you can just say clearly that maybe this is the slope of this. Is that not so?
yes, sir.
Okay, but technically using what we talk about, the limits, right? Because if it is no more straight, if it is straight, you can just check it. But assuming it's a curve, assuming it's just a curve, right? Is a curve that touches. Is a curve that touches, right? So you're required to draw either a tangent or a secant. And that is why at that point, you will now be taking you'll be seeing this particular notation because it is not accurately the exact change because you're taking, you know what a tangent, right? Is or a secant.
I don't know what's
Don't know?
mean of what seconds.
No, a tangent, if there is a curve and you want to find the slope, you just draw a straight line that closely touches it, right? And then you now take the slope like this.
Okay.
But you know how to take slope in your normal physics now.
Yes, there's enough to take the slope
Okay,
in
so
my
that's what we're
monocle.
saying. A tangent, you just draw a line to touch it. While a secant, you draw a line that passes it, and then you still take the slope. But in this case, what we are trying to solve is to tell you that we have rule for it. We have so many rules for it. One of the rule is the first principle rule, which I'm going to introduce you because you already know what limit is, right? I'm going to introduce it to you immediately because you already know what limit is. Now, from our first principle, we are going to be understanding that let's represent this curve, the change, instead of just the x, I can decide to represent this as, let me change the color. So that I just want to draw one as h. Is that not so?
Okay, yes, sir.
Good. And then if that is the case, and this is our f of x. So if this, I told you y represents f of x. So this is our f of x. Do you get that point?
Okay. Yes, I understand the point.
Okay, so at this, the difference between here to here, I can represent it as h. So this particular guy, this guy here, I can represent it as h. Similarly, this is f of x. But if I come to this place now, this is x1. This place is going to be what? F of x2. Is that not so?
Yes, sir.
Good. But I can do something very crucial here. I don't want to represent this as x1 and x2. So if I represent this as x, that means if I'm coming all the way here, I have moved a step further. That means I can represent this particular guy as f of x, but I have moved with a step plus h. Are we together?
Yes, yes, I
Good. So
understand.
that means this first y2, I can decide to write f of x plus h minus this y1. I don't want to write x not, I can write f of x. F of x. Is there any confusion
Okay.
up to now?
No confusion.
Good, no confusion. So the first principle states that this now give you the first principle. It states that if I want to get the differentiation of x, it's just like taking the limit as h tends to 0 of f of x, because I'm just trying to limit this to this particular curve, like we have learned before, all the explanation I gave you before. So this, how can I do this? It's just to take the difference between these divided by the step size, which is going to be taking the limit as h tends to 0 of this particular f of x plus h minus f of x upon h. This becomes the first principle formula. I'm telling you this because when you go to calculus, people will just be trying to cram this, just be trying to cram it. But for you,
No
you
problem.
already know where it's coming from. If I have a straight line, I can take the normal derivative. But if it is a curve, I can take the tangent. The tangent is just to draw a line close to it. You're taking the derivative. It's just to draw the tangent and then take the slope. By so doing, we got this. How do we got this guy? It's just from the second step. How do we get f of x? It's from the first step of y. How do we get h? H is not the step size, the difference between one intercept. So if I have another one, this is another h. If I have another interval, just the interval. No confusion, right?
Yes, sir.
Would be fantastic. So let's pick some. Let's now use first principle to differentiate a particular function. For instance, let's do, our y was equal to y. Let's say y is equal to x squared. Or we can even do y is equal to x. Now, from first principle, if I'm to differentiate this guy, y is equal to x, all I'm supposed to do is I'm going to put the function itself, the limit at h tends to 0. The function itself is x. But what will be f of x plus h? What will be x? That means in the function, because this is our function, f of x is equal to this guy. So anywhere I see x, I'm just going to put x plus h. That's what I'm looking for.
Mhm.
So in this place, I'm going to
Okay.
write x plus h, right? So what is
Yes,
our
sir.
f of x? Our f of x is just x upon h, upon h. Then I'll try to simplify. We have x here. We have this just, we can open this bracket now. This is the limit as h tends to 0 of x minus x plus h upon h. So we have the limit as h tends to 0 of what? X minus x, well, we are left with h upon h. And what is h divided by h?
Well,
No, h divided by h.
one.
Fantastic, 1. And that's how we got, when you differentiate x, you get 1. Are you getting it from the first principle?
Okay.
Good, from the first principle. So similarly, let's try and get this one too. If f of x is equal to x squared, let's try and get it from the first principle. Then I'm going to give you the general formula that make it easier. But this is the first principle and you are supposed to know it. So let me take out what is irrelevant here. This one is just an example, is irrelevant for us. Good. This one, we have it here, so I can take it out. So from first principle, we're going to solve x squared, right? So this is going to be the limit as x tends to 0. Our new function is now x squared. The function is x squared. That's f of x. So what is going to be f of x plus h? Simple. I will just come to the function. Anywhere I see x in this function, I'll just put x plus h. So that means this is going to be the limit as x plus h all squared minus f of x. F of x is what? X squared. So we have x squared. This will be upon what? Upon h, right? That's our formula. So let's try and evaluate this guy. So that's why you are required to make sure you know how to expand. So this one is going to give me x plus h minus x squared. This should be all over h. So we are going to continue here. So we have the limit as x tends to 0, then we multiply x squared, that's this, multiply by this, x squared, then this again, multiply by this, we have x h. So we'll do the second one, this, multiply by this, we have what? We have, there's another xh, then finally this, multiply by this, we now have plus h squared. So we have minus here, minus x squared, this final x squared, everything upon what? H. So do you see that there is x squared here and x squared here that can go, right? So we are now left with xh plus xh. This will give me 2xh. So we are now left with the limit as x tends to 0 of 2xh, because this and this I've combined them, and this one I have plus h squared. This is over h. What can I do here? As this, sorry, this is h. This is h tends to 0, h. So where did I make the mistake is here. H, not x, h. As h tends to 0. Because if I put h here, everything, h can never be 0. This is the condition. So what can I do here? I can factor h outside here. I have h here and I have h here. This is h. So I have the limit at h tends to 0. So I can remove one h here. I have h into, if I take out one h here, I have 2x. 2x. I take out one h here, I have h plus h. Then divided by what? By h. You can see this h can cancel this h. So I'm left with 2x plus h. And if I pass the limit now, I will now have 2x plus, instead of h, I pass the limit 0. So our solution here is what? Is 2x. Do you see it?
Yes, sir.
So this is from first principle. This is from first principle. From first principle. So believe me, if you continue, we have done for x, it gave us 1. We did for x squared, it gave us 2x. If we continue doing if we do x3, it's going to be 3x. If we do x raised to power 4, it's going to be 4x. If we do x raised to power 5, it's going to be 5x.
Perfect.
Good. All this, I can prove it for you from first principle. You already say we have time, so we can go
So
on now.
5x, you wrote 45.
4x, 5. What am I supposed to write?
You wrote 45 instead of 5x.
Fantastic. 5x. Good, good, good. So I know you're following. So because of this, we now came up, what about x raised to power n? If I don't know, if I know like x raised to power n, sorry, this one is 5x, but this one will be raised to power 2. This one will be raised to power 3, and then this one will be 5x raised to power 4. Because the power is decreasing. This place is like x raised to power 0, and anything raised to power 0 is 1. So that's why we have 1 times 1. Here is 2 raised to power 1. Here is 2 raised to power 2. Here is 3 like that. So scientists now say, okay, how can we generalize this? So we now came up that, okay, if you look at it, it simply is like, if I want to do for n now, can you see this place is like, what is, can you see it look like it's just 5 multiplied by, is the same n, but the n has reduced. Do you get? So when I do for 2, it's like 2 multiplied by x raised to power 1. So it's like 2 minus 1. So if for 3, it's like 3 multiplied by x, but this one has reduced, which look like 3 minus 1, which is 2. Similarly, 4 multiplied by x is like x minus 1, which is 4. So scientists now generalize that this thing actually look like, instead of this 5 now, it's like n multiplied by x raised to power n, but this n has reduced by what? By 1. Do you get the point now?
Okay.
So now scientists now came with a general formula that, okay, see, if it's just a power that has x raised to power anything, so we now just say is x. Let me make it darker. So the general formula is the one I'm going to write here. It's just x when x is to power n. So this is just n, x raised to power n minus 1. So this becomes the general formula for you doing polynomial of this nature, right? As simple as that. So if you are given, for example, I'm giving you what is x raised to power 11. So x raised to power 11 will be 11 x raised to power 11 minus 1, which is what? 11 x raised to power 10. So what is x raised to power 6? It's going to be 6x raised to power 6 minus 1. So this is going to be 6x raised to power 5. Do you have any question with this?
No, sir.
Fantastic. Do you need to take screenshot or can I continue?
Yeah,
You want to take
yeah,
screenshot?
I've taken screenshot. I've taken it already.
Okay, so fantastic. So now you can see that if I'm giving you y is equal to, let's give a long polynomial x is to the power 4 plus 5x cubed minus 4x squared plus 7x minus 2. And I ask you to differentiate, give me the y upon the x. Is the same thing as y prime. So if I say give me y prime or dy dx, I mean differentiate. So this first one is going to be what? 4x raised to power what? 4 minus 1. And instead of 4 minus 1, I can just write what? 3. Is that also
Yes, sir.
good? And while we're here, this is just going to be, keep this as a constant. So I have 5, but this will be what? Will be multiplied by this
X is about
3 into x minus, is that also
yes, sir.
good? So here, minus 4, I will keep it as a constant, but it will be multiplying x squared. So this guy, if I differentiate it, it's just going to give me 2x raised to power 2 minus 1, and 2 minus 1 is just 1. I don't even need to write it. So I just have this. Similarly, when it comes to this guy, plus, when I was solving for x, all I got was 1. So this is 7 multiplied by 1. But when you're differentiating a constant in calculus, it is equal to 0. So this is plus 0. You just leave it. When you're differentiating a constant, it's just 0. Good. So the final answer here will be 4x cubed. This multiplied by this will give me 15x squared. This multiplied by this will give me minus 8x, then plus 7. This becomes my final answer. Are we together?
Okay. Yeah, sir.
Good, good, good. So let me write some you will do later, but we are going to continue. So find the y, the x of the following. Oh, I don't need to write it. You know what you're supposed to find. So let me just write it. I'm going to continue just for you to screenshot and solve them later. So the question is
Okay.
y is equal to 2x raised to the power 5 plus 4x raised to the power 4 minus x raised to the power 3, then plus 3x squared minus 5x, then plus 7, 5x. Good. So do them, do that one, and then the second one is going to be 12x cubed minus 21x squared plus 8x plus 3. Good, 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 good. Right? So the next one we're
Yeah.
going to be doing is they can tell you to differentiate this at a point. They can tell you to differentiate this at a point. For instance, I can ask you to give me the value of dy upon dx of any function. Give me like say this function. The function, let me write the function first. The function is y is equal to 6x cubed minus 7x squared plus 4x plus 5. They now say give dy upon the x at x is equal to 3. They can give you a question like this. This is a function, differentiate it at x is equal to 3. It simply means I'm going to find dy dx, and then I'm going to now substitute 3. So how can I do this? So what is dy dx? Which is the same as y prime is going to be 3 multiplied by 6. 3 multiplied by 6 should be what?
Um, 4.
18. This multiplied by
18.
this is 18x raised to power 3 minus 1, which is 2. Do you get how to do it quickly?
Yeah, sir.
Then this multiplied by this is minus 14 x raised to power 2 minus 1, which is 1. I don't need to write it. Similarly here, I have invisible 1, 1 multiplied by 4. This will give me 4. Then here I have 1 minus 1. This is 0. Anything raised to power 0 is 1. Do you understand?
1.
Then
Yes,
here is
sir.
a constant. A constant, I told you, we don't use 0, right? So they are saying we should evaluate this at x is equal to 3. Very simple. So you already learned function. So this is 18 into 3 raised to power 2 minus 14 into x3, then plus 4. So this is 18 multiplied by 9 minus 14 multiplied by 3. What's 14 multiplied by 3?
Um,
14 multiplied by 3. What is it?
32.
42 plus 4. So what is 18 multiplied by 9?
162.
Is it?
162.
162 minus 42 plus 4. So this should give us
162
124
minus 43.
plus 4. So this give you that particular guy.
Okay.
So you can go and then do this ones for me. This is just find dy upon dx. Good. So I will now give you some of the rules, the remaining rules we have. Although I have told you the gradient is dy upon dx. I've also told you that we can differentiate them at a point where if y is equals to a constant, if we differentiate a constant, if we differentiate this constant is going to be 0. I've already told you if you have y is equal to x raised to the power n, if we take dy upon the x of it, we're going to get n x raised to the power n minus 1, which we have done. Then another summary, if we have a x raised to the power n, which is a constant I told you just now, all you need to do if you want to get dy dx, I showed you with this example, I'll just multiply them. So I have a multiplied by n, x raised to the power n minus 1. And then I just want to see if we have any other summaries. So we don't have any other summaries. So in 3 minutes, we are still going to do what we call second derivative. Now, second derivative, don't be confused. It's just when they say you should do y prime prime, which is the same thing as the now the second derivative, we can write it in the terms of that 2y upon the x squared. We are differentiating y twice. It's very simple. It simply means I have to do dy dx and still do dy dx of that particular one. You understand? So all I need to do is to do it 2 times. So when you're saying do y prime prime prime, it's very simple. It simply means I will differentiate the first time, differentiate the second time, differentiate the third time. Do you understand me?
Okay.
Okay, for example, this particular one that we have done before now, this one is dy dx. But if I decide to differentiate this particular one now, let's say somewhere here, I decide to do it for the second time. So I'm going to get this multiplied by this. So it's going to give me 36 x raised to the power x minus 1, that's 1. Here now I'm going to get minus 14 because x raised to the power 1 minus 1 is 0. This now become a constant, that's 0. So this become the what? The square y upon the x squared. Do you understand?
Okay.
But if I do it again, it now become what? That 3y upon the x cubed. Any confusion?
No, sir. No, sir.
No confusion, right?
Yes, sir.
Good, fantastic. So for now, I have introduced you to differentiation. So in the next class, we'll now be having all the rules. We have rules. We have chain rule, quotient rule, but basically this is what you're going to be doing. And then also, I'm going to send you what at your level you're not required to prove at all. You're just supposed to know them. When I differentiate cos, I'm going to supposed to get sine. If I differentiate this, I'm going to get this. There's a table for it. So I'm going to print the table and then send it to you. You understand?
Okay.
Good. So if you have any question, drop it on WhatsApp, but I'm going to do that immediately. So that in the next
Okay,
class,
sir.
we may touch it, then we'll now do physics. You understand me?
Okay, sir.
Okay.
Okay, sir.
Now feel free in the night time to always chat me up. And forget about the fact that we are trying to make sure you understand this thing within the month. Just feel free. You can drop the message